You know that game called Pictionary where you draw a picture and your teammates have to interpret what you've drawn? Well, in science, graphs are a bit like that. They are a visual representation of the experiment and its data. Unlike Pictionary though, graphs need to be really detailed. This video presents a review of some of the key tips for graphing data, as well as a couple of new ideas. There are lots of ways of graphing data, depending on what data you have, and many of these types of graphs you will have seen in maths and other courses at high school. So there's pie graphs, bar graphs, line graphs. We are going to look at a specific example that we will use most often in this course, and that's a scatter graph. Imagine that we've taken some data of a very exciting experiment in which we measured the position and time for a cart moving in a straight line. The data is recorded in a table, and of course these column headers have the variable name or symbol, so T for time, and the unit, which is in seconds, and the position, X, and the units in meters. It's really important to note that the values of your independent variable here, which is time, they don't need to be evenly spaced, because when those values are plotted on a graph, they will be in the appropriate place on that axis, and that axis will have a uniform scale. So the spacings on the axis, or the units on the axis, will be evenly spaced. So you see here that we jump from time equals 0 to 1 to 2, and then jump to 4, 5, and then all the way to 10. The table in itself is pretty boring to look at and is hard to interpret. So we want to graph the data in order to tell the story in an easier to understand way. So what do we need for a graph? Yes, in order to start graphing the data, we need axes. And these tell us something about which variables we're plotting and how and where to plot those points. So here are our axes. We need to label the axes with variables and units, and that allows your reader to interpret the meaning of the graph. Usually, but not always, we put the independent variable, time in this case, on the horizontal axis, and we put the dependent variable, in this case the position, on the vertical axis. The next important thing is that we need a uniform scale when we're drawing a scatter graph. Now if we plotted 1, 2, 4, 5, 10 on the axes like that, that would not be uniform scale. There would be different spacings between each of the divisions. So each of the time marks really needs to be an even spacing apart, and the same thing needs to happen for the position axis. So we'll take these away and draw all of those even spacings there, 1, 2, 3, 4, 5 up on the position axis. Now also we need to put in some negative values for the position axis, and this is okay because position actually does go negative. You can think of it as a vector. It can either be on one side of the origin or the other. So now it's time to plot all of these data points onto the graph. And we also need to show on the graph how uncertain we are about any individual point, and so we need error bars. So let's go ahead and plot those points, and they're error bars. So in this case, I'm going to say the uncertainty on the time is so small we can't even see it, but the uncertainty on any given position measurement is about 0.2. And so that's why those error bars are the size they are. They go 0.2 above the position dot and 0.2 below for each data point. When we look at our data that has been graphed, we want to interpret it in some way. We want to see what story it's telling us. Usually we're looking for trends and relationships, and perhaps where a trend line intersects the axes or how steep the slope is. So we need to draw a line or a curve of best fit. Now just a little reminder here, joining the dots is for primary school. So if I join the dots like I have done in orange there, it doesn't show the trend. It just says that between each of those data points, everything links up. So we don't join the dots. So we're going to remove those line segments there. and put in a line of best fit. And you see me adjusting it there. What we want is for our line of best fit, or the curve of best fit, to represent the trend of the data. So it needs to go kind of through the middle of the data, and there should be a random scatter above and below that trend line or trend curve. And you'll notice that about half of our points are below the line, about half of them are above. We don't necessarily want to join the first point to the last point, but we want it to show the general trend.
We also don't want to force the line to go through the origin or force it to go through any other specific point, because no point on this graph is more important than any other. Instead, we just focus on making that line represent the trend of the whole data set.
So this graph looks good, but it's not complete. If you gave this graph to someone else, they wouldn't be able to tell what the experiment was. So you might say, well, it needs a title. And that is true, and it's something that you probably would have done at high school. We're going to encourage you to start using something a bit more descriptive than just a simple title. We'd like you to use a caption that provides a full description of the experiment that this graph represents. So in this case, I've written a detailed caption. The position as a function of time for a mini electric toy car travelling at a constant velocity. The car was at a position of -0.8 at time equals 0. Post-it notes were used to mark the position of the car at each time step. A stopwatch was used to measure time, and a ruler was used to measure position. And I think you'd agree that that's a pretty comprehensive description of the data and of the experiment. So if someone came along, they could look at the graph, look at the caption, and get the whole story from just that. They probably wouldn't even need to read the rest of your report. So that's graphing data. You need axes, you need data points and error bars, you need a curve or a line of best fit, and you need a full description. One final reminder that joining the dots is for primary school, not for college.